In the next couple lessons, we'll take a closer look at the theory behind subdivision surface modeling and modeling in general, which is going to help you make more complex shapes. I would say the human face is definitely a complex object, and not something that I would expect you to be able to model right now. But as you watch this lesson, I want you to do a little bit of an exercise. Open up the Topology Examples blend file and enable the head collection. Then go to your toolbar and choose the annotation tool. Make sure the placement is set on surface. And then what I want you to do is go around the model and outline what you think are the major anatomical features that make this look like a human face. For example, we might draw a line that goes along the jaw and down towards the chin. I'll make the color of the annotation a little bit darker so we can actually see it here. But then we might also draw a line that goes around the eye, and a line that defines the eyebrow. We could draw one that goes down the nose and around the crease of the nose, one that goes around the laugh lines or around the piece of fat that creases up when you smile. We could draw a line that goes around the lips here, around the chin. Let's define the eyelid, the cheekbone, the cheek itself, and we could also move down to the neck and draw the main muscle that tapers to a V, the front of the neck. And we could keep going on and doing this down to the smaller and smaller details, but just take a second and try this for yourself. Then once you've finished, what I want you to do is go up to the overlays and turn on wireframes. Then notice how much that drawing lines up with the topology that we have for this object. Now, it's not going to be exact, but it's pretty darn close. If we tab into edit mode, I'll go to face select mode, and if I alt left click to select a face loop, then you'll see that we indeed have a face loop that runs all the way along the jaw and towards the chin. We have loops that run around the eye. We have loops that define the eyebrow. We have loops that define the nose, and the crease on the side of the nose that runs into the more bulbous shape. There are loops that run around the mouth, that make up that laugh line, define the chin, define the muscles, and so on and so forth. But the reason I wanted you to draw on this mesh first before inspecting it is that it's easy to look at a wireframe like this, especially as a beginner, and think that it's really complex. And it is. There's a lot going on here when it comes to the topological details. But even if the lines you drew are a little bit different than what the edges are on the model, I just wanted to show you that you probably already have a pretty good intuition on what the topology for this model should look like. You might not know the technical details of how to achieve this model, but as long as you know that you need to have loops that run along and define the most important features, then you already know what to do. The challenge is just how you do it, and that's what we'll be exploring in the next couple lessons. There are lots of different ways to model a head, but when I modeled this one, I did it exactly like I just drew with the annotation tool. I first created a loop that went around the eyes, I created a loop that went around the forehead, and I made all of these important features first, and then once those important features were defined, it was just a little bit of a puzzle to figure out how they all connect together. If you're curious, take a little bit of time and just select some of the loops that are going around the object and notice how they flow. Just kind of get used to that pattern and see how they define the features of the model. The second thing I want you to notice is where loops that are next to each other for a little bit split off and go in different directions. For example, here we have a loop that runs around the eyes kind of like a mask. And if we shift alt left click the one above it, you'll see that it runs in the same direction for a little bit, but then splits off and goes down the cheekbone and down towards the jaw and onto the neck. Well, right at the vertex where those split off into different directions, we have a really important detail. This vertex is connected to 5 edges, and that makes it what we call a pole. A vertex that's connected to 4 edges is just a regular vertex, but any vertex that has 3, 5, or more edges connected to it can change the direction of the loops around it. And you'll notice that anytime where you have loops that split off from each other, you'll find one of those poles. Let's say here and here. Here's another 5-sided pole. Let's say we have a loop here and here. Right where they split off, that's another pole. We can even have 3-sided poles as well. For example, this loop and that one, they head off in different directions, in this case crisscrossing each other. And right at the center of that crisscross, we have a 3-sided pole. So the important thing to know is that poles are how you direct edge loops and make them go in different directions. And if edge loops are what define our most important features, then poles are how we make sure that they're going in the right place and defining the features that we want. If we were to have a pole in a place where we don't necessarily want a change in direction of the topology and we don't want a feature, then that's going to cause some problems. For example, if I take this edge here and I'll hit M and merge at center, then we're going to create a big old pole right there. And in this case, it's created a couple of triangles, so the edge loops just stop right there and don't continue on in other directions. But if we were to look at this in object mode, then we're going to start to see a little bit of lumpiness appear in that area. So we'll talk a lot more about this in the next video. But for now, I just want you to know that vertices with 3, 5, or more edges are called poles, and that we have to be really careful about how we use them, because they can be extremely powerful in making sure our loops go in the right direction, but if used incorrectly, they can make our loops go in the wrong direction. And if loops go in the wrong direction, then it's defining details that we don't intend, and that's how you end up with lumpy and messy results. The third thing that I want you to notice on this model is how a lot of the loops connect right back in towards themselves. So for example, this loop goes all the way around the eyes, but if we enable the mirror in edit mode, you can see that it makes a complete loop. Same thing with the loops that go around the eyes, that makes a complete loop. The loop that goes around the nose and down towards the chin, the one that defines the chin and the jaw and the top of the head, these all form a closed circuit. Now you'll find some loops that are a little bit more complex, like the ones going through the ear. That's just a really complicated area, and so there's not really a good way to make that super simple. But for the most part, all of these loops start and stop in a way where they just loop in on themselves, and we can put an edge loop all the way around. Or they might end at different holes. So for example, the loop that runs from the eyes to the mouth, it doesn't form a complete circle, but it just starts at one and ends at the other. The important thing about this is that it's not running around the entire object. As a beginner, it's really easy to create loops that spiral in on themselves. So maybe instead of creating just a circle around the head, maybe it wraps around the head a few times and spirals down, and that's just not good practice. But more importantly than that, closing our loops helps us concentrate the details exactly where we need it. For example, we have a lot more vertices around the eyes and the ears and the mouth than we do the top of the head. That's because we need more details in those areas. Whereas on the top of the head, there's not a lot that we need to define. And a lot of the loops that are involved with creating the eye are only in the eye area. The loops that define the eye shouldn't be messing with the ear, or the loops that define the mouth shouldn't create problems on the back of the head. For example, we needed a good amount of geometry to create this ear here. So I used a couple techniques, which we'll talk about in the next videos, to make sure that the high concentration of detail stays in this area and doesn't run all the way around the back of the head. For example, if I were to add a loop here so that I could, more round out this ear part, then now the rest of my model is super messy. And not only that, when I look at the subdivision surface modifier, it's sharpening things up in a way that I don't want. If I were to add, a bunch more loops here just so that I could add more detail to the ear, then all of a sudden I'm complicating the entire rest of my model. So we're going to try to be careful and contain the detail to the area that it's needed. Of course, we'll always have some loops running from one detail to the next, but do notice how everything is pretty self-contained. So at this point in your modeling journey, I don't expect you to be able to make a model this complex from scratch. But I do want you to poke around a little bit and just notice the 3 things that we talked about in this video, because they're going to be some of the most important things to pay attention to while you're modeling. Number 1 is that loops are what define the details on your mesh. 2 is that poles are how you can direct your loops to go in different directions. And 3, how our loops are as simple and self-contained as possible. Then in the next couple of videos, we'll talk about how to actually put this into practice.